Yeah, hi all. So, still have stopped at lag. So, lag means for the to get the previous record value. Now, lead means it is used to access the subsequent row data along with the current row data. Okay, it is used to next row value within the same table. So, syntax for this is lead expression offset on default value over order by columns. Expression, it is a scalar expression evaluated against the value of the row at a given offset prior to the current row. So offset means it is a number of rows that you want to backward from the current row. Default is 1. Okay. The default means if the offset goes beyond the scope of the partition, the function returns the default. If you omit defaults, then the function returns null value. So simple example for this, select employee number, employee name, job, salary, lead, salary, comma, 1, comma, 0. Okay, that is lead expression offset default value over order by salary descending, and this is the column alias name next value I'm giving here. So president, it is having the 5,000 for this. Next record is that is 3,000. So that it is giving 3,000 for the Scott salaries for 3,000, and here next row record is 3,000, and for this analyst next record is 2975. For this manager next record is 2850. That means subsequent record value. So coming here for the last record, there is no next record, so that it is giving 0 here. So yesterday when you use the lag, what happened? For the first record, previous record is null, so that it is taking 0 here. But coming to the lead, for the next record it is 0, so that for the last record it will be 0 here, or null values. Okay, same you can use the using with the hide date also, same thing. Some of the examples here. Select employee number, rename job, salary, hide date, lead, hide date, comma 1, comma sys date. That means wherever the value is not there in place, that it will be replaced with the sys date. See, this clerk is there. For this hide date is 17 December 18, and next hide date is 20 February 81. That is added here, next value. And for his 20 February 81, next value is 22 February 81. That is added here. So like this, coming to last record. So there is a known next record for this, so that today's date is added, this date, 25 April 25. So lag means previous record, lead means next record. Okay, that you have to remember. So next we have the nulls first and nulls last. So what it means? So nulls first, nulls last means ఇప్పుడు select star from EMP. Okay. So here if you see, here is the commission is null in some of the columns. Okay. So if you order I want the order. So first one, I want to display all the nulls. After that, only values. Then order by commission descending. So when is the order by commission descending, what will happen? So there is no here nulls only, same it is there. Coming to here, what are the values there in the commission? It is in the arranged in the descending order. But still I want the nulls to be first. Then what I have to do? Descending order nulls first. Okay. Then all the nulls will come here first. After that, these values will come. So suppose if you are not using this order by clause, it will throw the error. So within this order by clause, we have to mention that order by commission. Okay. So instead of the descending, I will mention nulls first. Then it will come like this. So nulls last means, so first all the values it is coming here. So here also if you see this, first what are the values in the commission column? These records it is, first it came, after that null values come. So within this commission also I want to in the descending order, then you can mention in the order by commission descending. If you see here 0, 350, 500, 1400 is there. Now it will change to 1400, 500, 300, 0. After that nulls it is coming. So based on our requirement, we can use this nulls first and nulls last. So same way, we take in this analytical function. So select employee number, employee name, salary, commission, rank, over order by commission descending nulls first. That is rank nulls first I am giving. And next we have the dense rank. Dense rank over order by commission nulls first. Dense rank nulls first. So how we are using this nulls first and nulls last in this different scenarios here. So if you see this employee number, e-name, salary, commission, in the commission column, nulls last it is showing here. And coming to this rank, if you see all the null values came here first. For that it is giving first rank here. It is all having the, that means null means it is all having same value. So that it is 1 it is assigned. After that rank it is assigned 14, 13, 11, like in this order. Okay. So same way coming to the dense rank, it is assigned all the nulls, it is assigned 1 it is, and after that 2, 3, 4, 5 it is assigned based on the commission column. So here if you see order by rank and the descending order I mentioned, so that it is came like this 11, 12, 13, 14 it is in the reverse order it is came. If I remove this one, what will happen? So all the nulls it is assigned 1 same, and for this 0 it is 11, 12, 13, 14. Same way here dense rank it is not skipping the next sequence, whereas in the rank it is skipping the next sequence. If you see this, all the records up to 10 records it is having 1, so that next record it is assigning 11. Okay. Same way you can use this nulls last also. When you use the nulls last, what will happen? So it will assign the Same rank for this. Okay. So you can remove this discernment so that it's easy to. So here commission 0, 300, 500, 1400 is there. For that it is rank is assigned 1, 2, 3, 4. After that all the nulls it is assigned 5. Same way here also in the dense rank it is assigning 1, 2, 3, 4. After that 5 for all the null values. Same for is so here over rank partition by department number order by commission descending. Here also I'll take commission descending. Okay. Then first it will so if you see this order partition by department number, first partition by department number 10, 10, 10 it is came. After that 20, after that 30. So within this there is no change for this commission. If you see the commission descending nulls, commission descending nulls means what it here within this department nulls it will be last. So if you consider this department number 30, you can clearly understood first it is values are there, after that null values it is coming. But for the department number 20 and 10 there is no value, so that it is giving all the nulls only here. So partition by department number, after that commission in the nulls last. So see here in this department number 30 you can able to clear. So next we have the flashback table. Okay, this is the command it is used to restore dropped objects from the recycle bin. So this command what it will do, restore the dropped objects from the recycle bin. So like in the Windows we have the recycle bin folder. So whenever you delete any file, it will move to the recycle bin. If you don't want, you can permanently remove from the recycle bin also. So if you want to restore from the recycle bin, you will go to that recycle bin and select that file and restore, so that file will be restored. Same way in the Oracle also we have the flashback table. So this command is used to restore the dropped object from the recycle bin. So how will you use this? Syntax is flashback table name to before drop. So example is flashback table emp1 to before drop. Suppose if I do that, original name is used to by existing object. So that means this is not deleted. Suppose I will drop the table. But in the real life, don't drop in the real time scenarios. You don't drop the tables without your team leader manager permissions. Okay, even though if you create any sample tables also, you should not delete tables. Okay, so why? Because when you delete immediately, they will ask why you deleted. You have to give the proper answer for that, whether the table is not required or it is not using. That answer you have to provide, but that should be with the concern of the your team leader manager. So in the real time scenarios, are in your job time. So you should not delete any table which you created for the temporary use also. You should not delete them. Okay. So your manager or management they will take the decision for the unnecessary tables, what to do, whether to delete or not. They will decide it. Then only you have to delete until unless. So what are the tables you have created? You should not delete. Okay. So I'm dropping the table EMP1. Okay. Table is dropped. So now if you check this, table exists or not, select start from EMP1. Then it is saying table or view does not exist. Now what I will do? Flashback table EMP1 to before drop. Flashback succeeded. Previously, before deleting, when I use this, it is throwing the error. Version name is used by an existing object. That means object is not deleted, so that flashback is not worked at that time. So once after dropping this table, when I use this flashback, then it is flashback succeeded message it came. Now you can check this again. Select start from EMP. Then that data is there. Okay. This is about this flashback. Whenever by mistake if you drop the table, so you can use this flashback. But in the all the scenarios, you may not be having this option. Means DBA will not give permission all the permissions. Okay. So don't delete any table without your manager consent. Okay. Next we have the purge. So purge it is a command used to drop objects from recycle bin permanently. So that means suppose if you drop the table, then from the recycle bin also if you want to delete permanently, then you can use the purge option, purge command. The syntax is purge table name. Suppose now I am having the table present in this. Okay. So now I will do purge table means table purged. Okay. So now you can check this table. Still table is exist. Table purged it is saying, but still table is exist. That means it is not in the recycle bin. When it is in the recycle bin, then only table will be purged permanently. So now I am going to drop this using drop table EMP1 purge. So this table EMP1 purge dropped. Now check this. Table is not there. To purge any table without sending to the recycle bin, you can use the drop table EMP1 purge. So it will not go to the recycle bin. The drop table will not go to the recycle bin, and you cannot use this. Once you purged, then you cannot get back using the flashback also. Why it is coming? Okay, I'll do first purge delete drop table. Now if I drop the table, then it is so table is not exist, and drop table purge table are be not exist. Okay, purge table now. Table purged. Now I can use there is no table, but if you use the flashback succeeding, table is getting. Okay, actually here it is getting back again with this flashback command, but in the actual scenario, so purge means it will permanently delete from the recycle bin also. But I don't know why it is coming here. Okay, so these commands you should not use in the real time, but you should be aware of this so that explaining this. Okay. So we'll move on to next topic, that is indexes. Index. What is the use of index? Anyone knows? Okay. So index, why we have to create index? Without index, what is the disadvantages? With the index, what is the advantages? So index also is a database of the object which is easy to retrieve data from table quickly. A database index will work as a book index, as a book index page in the textbook. That means in the textbook we are having the front page, you will have the page numbers and topic wise. So this topic will be available in this from this page onwards, like that. So that we can go to that page directly, or you can open that topic directly by using that page number. Same way in the queries also, index means it will generate one index number for the whatever order we are taking for the index. For that it will generate, so that whenever you are fetching any data, so straight away it will go to that particular location and it will retrieve the information instead of scanning the entire table. Okay, by using indexes we can save the time and improve the performance of the database. Index object can be created on a particular column or columns of a table, and these columns are called as a index key columns. Index uses TrueID to fetch the data from table. Use of the indexed column to improve performance. All databases are supporting the two types of searching mechanism. These are table scan method, that is default method. Another is index scan. So table scan means it is a default scanning mechanism for retrieving data from table. In this mechanism, Oracle server is scanning entire table top to bottom. Suppose we use the select salary from EMP, where salary is equals to 3000. So what will happen when you run this query? So it will check all the available options. Okay, that means where it is. So first it will, what it will do, from the employee table it will verify all the salary column details. When this is found, then it will retrieve the information like this. Suppose if you are having the salary column, it is 800, 1600, 1250, 2975, like this. So it will scan all the entire salary column, and when it found where salary is equals to 3000. In this table scan, we are comparing where condition with 14 times. Okay. So each condition it will verify with whether it is equals to 3000 or not. So how many times it will compare? So in this employee table we are having 14 records, so that it will compare 14 times. So where it finds, then it will display this 3000 value. That is full scan. So next we have the index scan. Okay. In the index scan, we have the scanning only indexed column. In index scanning mechanism, Oracle server scans only indexed columns from a table. So type of indexes we have the B-tree index, and we have bitmap index. Okay. So these two type of indexes are there. In this again, B-tree index, we have the default index, simple index, composite index, unique index, okay, function based index, reverse index. So B tree index it stands for the balanced trees. It is an ordered list of values divided into range along with the row ID information stored in the index segment. So B tree index are suitable for containing high number of volume. High number of volumes like that means employee numbers, bank account numbers, mobile numbers, PAN card, Aadhaar card information. So all will come under high volume information. So under this we have the simple index, composite index, unique index, function based index, reverse key index. So we'll create a table with name emp underscore idx underscore 25. So employee number, employee name, job, salary, department number. So I'm creating the table with this name. So I'm going to insert some records into this. Insert into this table. Insert into emp underscore idx underscore 25. Select employee number, employee name, job, salary, department number from emp table. Okay, 14 rows are inserted. Now I'll use the commit command. So table got created here. Coming to okay, this is the table we created, and this table we are inserted some data. Now how will simple index works?
Bluetooth mode.
Okay, simple index means when we create an index on a single column, then we call as a simple index. So how it will works? So when you create an index on the single column, it is called as a simple index. So create index, index name, and table name, column name. So now I'm going to create the index on this table. Create index id1 underscore 25 and emp underscore idx underscore 25 table name, and of the column name employee number. Before that, can we check any index are there in this? We can use this open declaration or open pop-up describe. Okay, so in this you can see constraints, grants, triggers, flashback. So how many flashback means what is the data inserted in this table or not? All the information will be available here. Dependence, details, and partitions. Here there is no index, it is mentioned, so that we can select open pop-up declaration. So here if you observe, columns are there, data, what is the data in this, and model. Okay, so indexes are there. So index, there is no index now at present on this table. Okay, so I am going to create index id1 underscore 25 on emp underscore idx 25. with the employee number column. So index is created. Now you can verify here. See this ID1 underscore 25. And the column name employee number. Okay. So once it is created, so it is displaying here. Before creation, there is no information here. Okay. So next we have the composite index. Composite index. So when we create index on a multiple columns, then we call it as a composite index. So how it will works? Create index, index on index name on table name, column name 1, column name 2, like that. So if you create a on a single column, it is called as a simple index. If you create a index on multiple columns, then we can call it as a composite index. Create index ID2 on EMP underscore IDX. With the job and salary I'm giving here. Okay. Here index is created with this composite index. Okay, check this one here. So ID1 underscore 25, ID2 underscore 25. Okay, this is on the job and salary. This is a composite index on the two columns, job and salary column. And this one on the single column only, simple index. This is on for the simple index and this is for the composite index. So next we have the unique index. So when we create index based on a unique constant column, it is called as a unique index. So unique index does not allow duplicate values. So whenever you are using the unique index, so it should not contain any duplicate values. So syntax is create unique index, index name on table name, column name. So on which we can create unique index. We can create index based on the unique constraint column. That column which is having the unique constraint on that column, if you create index, that is called as a unique index. Suppose if I am trying to create a unique index on the salary column. So what will happen here? So create unique index ID3 on EMP underscore IDX underscore 25 on salary column. It is throwing the error. Name is already used by existing object. ID3 okay. Table name is same only. Okay. So name is already used by the existing object. So that create unique index